Jupiter Unraveled. Epic storms, mighty moons, and cosmic wonders. Welcome to my channel. Before we dive in, if you enjoy my content, please hit that subscribe button and turn on notifications so you don't miss any updates. Today, we're going to explore a comprehensive array of facts about Jupiter. Here's the list of topics we'll be covering. 1. Jupiter's massive size. 2. The Great Red Spot. 3. Jupiter's moons. 4. Jupiter's rings. 5. Jupiter's magnetosphere. 6. Jupiter's role in the solar system. 7. Space missions to Jupiter. 8. Jupiter's potential for life. Join us as we delve into each of these fascinating aspects of the largest planet in our solar system. Jupiter sizes. Jupiter is renowned as the giant of the solar system, and for good reason. It is the largest planet orbiting our Sun. Here's a detailed look at its massive size and how it compares to other planets. Absolute size and mass. Jupiter's diameter is about 142,984 kilometers, 88,846 miles, making it about 11 times wider than Earth. In terms of volume, it could fit more than 1,300 Earths inside. With a mass approximately 318 times that of Earth, Jupiter is twice as massive as all the other planets in the solar system combined. Gravitational dominance. Jupiter's immense mass exerts a powerful gravitational pull, which has significant effects on the orbits of other bodies in the solar system, including comets and asteroids. This gravitational force is also responsible for the intense pressure and heat in Jupiter's core. Atmospheric heft. Jupiter's atmosphere is incredibly thick and composed mainly of hydrogen and helium, similar to the composition of a star. In fact, if Jupiter had been about 80 times more massive, it could have had enough pressure and temperature at its core to ignite nuclear fusion, becoming a star rather than a planet. Comparative size. If the Sun were the size of a typical front door, Earth would be the size of a nickel, and Jupiter would be about the size of a basketball. Jupiter is more than 3 times the diameter of the third largest planet, Uranus, and more than 28 times the diameter of the smallest planet, Mercury. Rotational influence. Despite its enormous size, Jupiter has the shortest day in the solar system, rotating once approximately every 10 hours. This rapid rotation causes the planet to bulge at the equator and flatten at the poles, creating an oblate spheroid shape. Impact on the solar system. Jupiter's size and mass give it a strong magnetic field, which, along with its radiation belts, creates a hazardous environment for spacecraft. The planet's gravitational influence likely played a role in the solar system's formation and evolution, affecting the orbital arrangement of other planets and the asteroid belt. In summary, Jupiter's massive size is not just an astronomical fact but has far-reaching implications for the dynamics of our solar system. Its immense mass relative to other planets has endowed it with a gravitational pull strong enough to have shaped the past and to continue to influence the future movement and formation of celestial bodies within our solar system. Jupiter's size and mass are testament to its role as the dominant planet in our cosmic neighborhood. Great Red Spot. The Great Red Spot is one of the most iconic features of Jupiter and has been a subject of fascination since it was first observed through telescopes in the 17th century. Here's a comprehensive explanation of this colossal storm. Nature and appearance. The Great Red Spot (GRS) is a gigantic storm, a high-pressure anticyclonic storm system, located in Jupiter's southern hemisphere. It appears as a distinct reddish-orange oval and stands out against the swirling bands of Jupiter's atmosphere. The color of the GRS is thought to be due to complex organic molecules, red phosphorus, or other compounds that are brought up from deeper within Jupiter's atmosphere by the storm. Size and scale. The storm is massive, measuring about 16,350 kilometers, 10,159 miles, in width as of April 2021. This is 1.3 times the width of Earth. Its size has been observed to change over time, shrinking in length but growing in height. It was once large enough to fit 3 Earths across its width. Duration and dynamics. The GRS has been raging for at least 350 years, and possibly much longer. It rotates counterclockwise, with a period of about 6 Earth days. The storm's longevity is believed to be due to Jupiter's lack of a solid surface, which allows the GRS to maintain energy, and its position in a stable atmospheric band that's free of disruptive weather patterns that might dissipate it. Internal wind speeds. Wind speeds on the edge of the storm can reach up to 430 to 680 kilometers per hour, 270 to 420 miles per hour, far exceeding the strength of terrestrial hurricanes. Scientific study. The Great Red Spot has been studied extensively by various missions, including the Voyager flybys, which provided the first detailed images, and the ongoing Juno mission, which has been providing unprecedented close-up observations since 2016. Juno's findings include discoveries about the depth of the GRS, which extends much deeper into Jupiter's atmosphere than previously thought, and about the temperature and dynamics within the storm. Theories about its persistence. While the exact reasons for the storm's persistence and longevity are still being studied, some hypotheses suggest that the GRS is stable because it's trapped between two jet streams that flow in opposite directions. It has also been suggested that the storm is powered by heat from Jupiter's interior. Recent changes and future. The GRS has been observed to be shrinking and changing color in recent years, leading scientists to speculate about possible changes in its behavior or longevity. Monitoring the Great Red Spot continues to be a significant focus for astronomers using both ground-based telescopes and space missions to understand not only Jupiter's weather but also atmospheric dynamics more broadly across the universe. In summary, the Great Red Spot is a fascinating feature of Jupiter, symbolizing the dynamic and extreme nature of the planet's atmosphere. As a subject of continuous observation and study, it provides scientists with valuable insights into meteorological phenomena on a scale far beyond anything possible on Earth. Jupiter moons. Jupiter's moons represent a diverse and complex system that rivals that of a solar system in miniature. As of now, Jupiter has 79 known moons, but the most famous and the largest are the Galilean moons, Io, Europa, Ganymede, and Callisto. Named after Galileo Galilei, who discovered them in 1610, these moons are fascinating worlds in their own right. Io. Io is the innermost of the Galilean moons and is the most volcanically active body in the solar system. Its surface is dotted with hundreds of volcanoes, some erupting lava fountains up to 500 kilometers, 310 miles, high. Io's intense geological activity is due to tidal heating, the result of gravitational tugging from Jupiter and the other Galilean moons. Europa. Europa is slightly smaller than Earth's moon and is notable for its smooth, icy surface, which is crisscrossed by a network of streaks and cracks. It's believed to harbor a subsurface ocean beneath its ice crust, potentially twice the volume of Earth's oceans. This ocean makes Europa one of the most likely places in the solar system to find extraterrestrial life, as it could offer the conditions necessary for life to develop. Ganymede. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury. It is the only moon known to have its own magnetic field. Ganymede has a varied surface, with a mixture of older, heavily cratered regions and somewhat younger, grooved terrain, indicating some geological activity in its history. Callisto. Callisto is the third largest moon in the solar system and is the most heavily cratered object in the solar system. Its surface is marked by numerous impact craters and ancient basins. It appears to be a long-dead world, with little geological activity on its surface. Callisto is believed to have a subsurface ocean, like Europa and Ganymede. Other notable moons. Beyond the Galilean moons, Jupiter's other satellites range from tiny moonlets to substantial worlds in their own right. These include Amalthea, the largest of the inner moons, and Himalaya, the largest irregular moon. Scientific importance. The moons of Jupiter are of great scientific interest because they offer insight into the conditions of the early solar system. They also act as natural laboratories for studying geologic processes, potential habitability, and the possibility of extraterrestrial life. Future exploration. Missions such as NASA's Europa Clipper and the European Space Agency's Jupiter Icy Moons Explorer, JUICE, are planned to further explore these natural satellites, particularly the potential habitability of Europa and Ganymede. The moons of Jupiter, with their unique features and potential for harboring life, are central to our understanding of the formation and evolution of planetary systems. They continue to be the focus of intense scientific study and the targets for future space missions. Jupiter's rings. Jupiter's rings were a surprise discovery made by the Voyager 1 spacecraft in 1979. Unlike the splendid rings of Saturn, Jupiter's rings are faint, thin, and composed mainly of dust particles. There are three main sections: the innermost, halo, ring, the main, bright, ring, and two gossamer rings named after the moons Amalthea and Thebe. These rings are likely formed by dust thrown up by impacts on Jupiter's small inner moons and possibly from material ejected from the planet's atmosphere due to electromagnetic forces. Jupiter's magnetosphere. Jupiter's magnetic field is the largest and most powerful of any planet in our solar system. It extends up to 7 million kilometers toward the Sun and almost reaches Saturn's orbit on the side farthest from the Sun. Generated by the swirling liquid metallic hydrogen in Jupiter's outer core, this magnetic field traps high-energy particles, creating intense radiation belts. It also produces auroras at the planet's poles, much like Earth but far more powerful. Jupiter's role in the solar system. Jupiter's immense gravity has a significant influence on the solar system. It can alter the orbits of bodies passing through the outer solar system and is thought to have done so throughout the history of the solar system. This has led to the theory that Jupiter acts as a sort of cosmic shield, particularly for Earth, by redirecting or capturing comets and asteroids that might otherwise pose a threat. However, this role is complex, as its gravity can also send objects on a collision course with Earth. Space missions to Jupiter. Historically, several missions have visited Jupiter. The Pioneer and Voyager missions provided early reconnaissance, revealing much about Jupiter's moons, rings, and magnetosphere. The Galileo spacecraft, which arrived at Jupiter in 1995, dropped a probe into the planet's atmosphere and spent years studying the planet and its moons. The Juno mission, currently in orbit around Jupiter, is collecting data on the planet's atmosphere, magnetic field, and gravitational field, revealing secrets about the planet's interior structure and water content. Jupiter's potential for life. When it comes to life, interest is focused not so much on Jupiter itself, given its extreme and inhospitable conditions, but on its moons. Europa, with its subsurface ocean, is considered one of the most likely places to find life beyond Earth. The water beneath its icy crust might be in contact with the moon's rocky mantle, providing the chemical ingredients and energy sources necessary for life. Ganymede and Callisto may also have subsurface oceans, making them subjects of astrobiological interest. Future missions, such as the Europa Clipper and JUICE, are aimed at investigating these oceans and their potential for supporting life.